Before we get started, wanted to let everyone know that our speaker today is happy to take questions throughout the webinar, and at the end, there will be time for a Q&A session. So if you have questions, please submit them in the comments or the Q&A section as they come up throughout the presentation, and we will be sure to get to them. So, with that said, let's go ahead and get started by introducing our speaker for today, Dr. Tim Oates. Hi, Tim. He is the co-founder and chief data scientist here at Synaptic, with over 20 years of experience in guiding organizations and companies of all sizes, applying AI and machine learning to business problems across industry. Tim earned his PhD in computer science from University of Massachusetts Amherst with a focus on AI and machine learning, and was a postdoctoral fellow at the MIT AI Lab. Thank you, Tim, for joining us and speaking with us today, and I'm going to let you take the presentation from here.
Okay, sounds good. Thank you, Sam. I appreciate it. As Sam today said, we're going to talk about agents. And actually, I did a 10-minute version of this webinar at an all hands meeting inside the company. And Steven Sklar, our CEO, put this slide together, which I thought was amazing. So I decided I'd use it here as well. I will say a lot of what we're going to talk about today is the what of an agent. And I'll have an outline in just a minute. So it's a lot of what makes an agent. Why would you use agents? Less about the how, but I'm also very happy to address that during, questions. So just really briefly, I wanted to talk about the company a little bit. We started out about 10 years ago doing AI and machine learning consulting. So it was me and Steven doing projects that were relatively small. Well, we've grown over time, both in terms of the sizes of the projects that we do and the scope of the things that we do. So we branched out into data engineering, user experience. So what we found was over time that companies would hire us to build the AI components of things that they were working on, and then we would hand it over to them, and then they would sort of integrate it into their product. But it turns out that it's also a lot of fun to work on the user side of it. So now we think of ourselves as an intelligent products company where we do everything from sort of moving the data around to doing AI applications with it to integrating that into a meaningful experience for the people who are ultimately going to use it. So the outline today is as follows. As you saw, the title of the slide is actually stolen from a paper that came out in the 1990s, I think. We'll get to that in a minute. So agentic AI is a buzzword in the industry these days. So we'll talk about the hype a little bit. Then we'll spend a fair amount of time talking about what an agent is. And it turns out that one thing that agents do is that they're supposed to think. And we'll sort of think about thinking a little bit, just briefly. Then we'll take a different slice through what an agent is. Instead of talking about kind of what they do, we'll think about some capabilities that they have and then have some use cases and concluding thoughts. So, um, as Sam said at the beginning, please feel free to ask questions. I'd be very happy to stop and answer questions. I can't see anything but my screen, but Sam is monitoring the chat and she'll interrupt me if need be. So let's talk about the hype a little bit. Here is this quote, and I don't know if you've ever heard it before. I want to read it to you because it's very interesting. This was by Herb Simon of the duo Simon and Newell, who are powerhouses in AI and a couple of other fields. And Herb Simon said, "It is not my aim to surprise or shock you, but the simplest way I can summarize is to say that there are now in the world machines that can think, that can learn, and that can create. Moreover, their ability to do these things is going to increase rapidly until, in a visible future, the range of problems they can handle will be coextensive with the range to which the human mind has been applied." Note he said that in 1957, and he was saying that about a thing called the general problem solver. So, Simon and Newell, or Newell and Simon, built a couple of things back in the late 1950s. One of them was a general problem solver, which was this sort of reasoning engine, which today we would categorize as being old school AI. And they were really impressed with what they had built for good reason at the time. But it turns out that it's just that tackling AI problems with rules is too hard. And everything that you want to do takes forever, and it wasn't workable. Now, that certainly led to lots of other sort of very important developments in AI. But hype has been around for a while. I stole the title of my talk from this paper, Support Vector Machines Hyper Hallelujah. That's a paper that came out, I believe, in the late 90s, and it was about a different technology. It was a machine learning technology for solving classification problems. And as you can see in the upper right-hand corner, if I've got, some data points that live in a two-dimensional space, and some of them are green and some are blue, and I want to find a way to separate the two. Turns out support vector machines do that really well. I still teach support vector machines in my machine learning classes when I do that. And again, so people got really excited about support vector machines. But then, we're here again. So as I was preparing for this webinar, all I did was I went to Google and I typed in the query agentic AI news, and I came up with these, right? So, um, there's Sam Altman from OpenAI saying agentic AI systems will provide enormous uplift in business performance, and on and on and on, right? So Walmart bets on AI super agents to boost e-commerce. So everybody's talking about AI agents. And so, part of what I want to do is just say today, here's what an agent is, here are the capabilities that they have, and why now? Because working agents has been going on since I was in grad school back in the 1990s. So, but I do think, my personal opinion is at this time there's something truly different. And really the thing that's different is that the agents are way smarter. So an agent you can think of as being just a large language model. It's a chat GPT sort of doing something in the background. And the difference today is that the agents are incredibly capable individually. So, but you have to kind of be careful. You have to be a cautious consumer of the technology and look out for overhyped claims. And we'll come back to that in a minute. So, um, with that background, I want to then talk about what an agent is and actually what do agents do. So, if you look at the literature, sort of the research literature, if you look at the popular press when people are trying to explain agents, there's this little loop, right? It's I'm going to sense, I'm going to think, and I'm going to act. And actually, that's a pretty good approximation of what I think I do all day. I kind of, I look around, I see what's going on, I think about what I need to do next, and then I take some action. And depending on what happens when I take some action, the world changes, and I'll look around and just do it over again, right? And so sometimes there's more thinking and less thinking. When I'm driving to work, I don't think a lot about what I'm doing. When I'm teaching, I think, harder about what I'm doing. Or when I'm writing, I think really hard about what I'm doing. So an agent engages in this cycle. Here's a couple of examples. So up there is an old school thermostat, and thermostats sense. So you set the temperature that you want. There's a sensor in there that says what's the ambient air temperature. And if the temperature is too high, it will take an action, right? It will turn on the air conditioning. Or if the temperature is too low, it will turn on the heat. So there's certainly sensing and acting. I don't know how much thinking is going on in there. There are papers that I read when I was a grad student that were arguing, are thermostats intelligent? I think that's nonsense, but I don't know. You can see where you could have the argument. And there's a cat. Um, Cats sense and act for sure. I think they do some thinking. Um, I had a cat one time that would hang out in the front yard, and when I got home from work and I was walking up the driveway, it would walk towards me, but it would always aim for where I was at the current time. And so it wound up sort of tracing out this curved path and coming in behind me. So he was definitely thinking, I was like, oh, I want to try and catch up with this guy, but wasn't real smart about it. But then now we've got things like ChatGPT. So we have large language models. And they certainly can take actions. We'll talk about that a little bit. And the question is, are they thinking? And that's sort of that little interlude on thinking that we'll look at. But really, the sort of the power of modern agentic AI systems. The reason we're talking about them is because of things like large language models. All right, so I'd like to talk about sensing, thinking, and acting. And this slide is a wall of text, but hang on for just a minute, and we'll kind of dig through it. So there's a wall of text here because if you want to look at the slides later, you can sort of look at all of these things. But there's types of agents on the left-hand side, the environment that they live in, their sensing modality, and just examples of things that they sense. And so you can have robotic agents, game playing agents, software agents, DevOps agents. we're just going to look at a couple of them. So I just want to talk through two of them. Robotic agents are actually sort of easy to think about in terms of sensing. I got a robot, it exists in the physical world. It can have standard cameras. It can look at other sort of spectra using LiDAR. It can have an IMU, an inertial measurement unit, which lets it sort of, what you've got in your iPhone, actually, right? It lets it know sort of how it's oriented in 3D space. So it can get all these sensors and the kinds of things it might want to do, or, hey, is there a person in front of me? Is there an obstacle? Can I follow something that's moving through the visual field? And so notice that there's this distinction between kind of sensing and perceiving. I get this raw camera data or video data streaming in, but I want to perceive obstacles or kind of higher level things. In a completely different world, you can think about a DevOps agent. So you got an agent that's trying to keep your infrastructure you're up and running, right? So I've got my development environment, I've got some cloud infrastructure. The kinds of things it might look at are log files. I might query databases. I might sort of parse files that are in the system to extract information. And what I'm doing, the things I'm trying to perceive are build failures. Are there system states that might indicate whether things are going right or wrong, right? So the first thing an agent is able to do, like these sort of three capabilities, as I said, we'll take a different slice through it in a minute, is they can just look around the world and gather information, but the information that they're gathering is very specific to what the agent is trying to do. So thinking is exactly the sort of you might in the robotic agent sense, now that I've actually figured out that there are obstacles, what I need to do is how do I deal with that? So I might engage a path planning algorithm. So an agent is going to have tools that they can call out to. So, oh, there's an obstacle at this particular location. Let me call a path planner, and that path planner is going to tell me you need to go over in that direction because the object that you want to grasp is over there, but you need to move around, right? So now I'm going to think about what I do. The DevOps agent might go, there's an error, right? So the latest build of the system failed. Now that I found that, let me actually think about what might have caused the error. Can I run some tests to try and figure out what's going on? And then the acting side of it, again, for the robotics agent, the acting is sort of physical movement. So I'm going to turn my wheels so that I can follow that path that I planned out. I might move my gripper and sort of manipulate an object. The DevOps agent might run a test or edit a config file or restart a service. And so now and then you can see the DevOps agent goes, well, maybe I just needed to restart that service. I'll restart that service. I'll run the build again and then I'll sense. And maybe this time the build will run to completion or something else is going to happen. So that's the life cycle of an agent. That's sort of all they're doing. Now, I do want to talk for a couple of minutes about the thinking side of things because it's it's sort of easy to imagine computer programs and other kinds of things sensing. Computer programs are always reading information, doing stuff with it and then causing other things to happen, like writing files or whatever. So there is this beautiful old book. It's called Vehicles by Valentino Bratenberg. So these are called Bratenberg's vehicles. And just real quickly, the entire thing is a discussion of how you can build these little vehicles that exhibit very realistic, lifelike, human-like behaviors, and all they are is sort of different wires. And I'll explain two of them to you. Um, you know, again, like quick read, you can read this thing in 3 hours. It's wonderful. So the way to think about these things is here's a vehicle. It has this light sensor, right? And so the more light that gets to this thing, because it's a positive connection, the faster the wheel turns. Okay. So here's a light. Notice that this sensor is closer to the light than this sensor. So this gets more energy, which means that this wheel is going to turn more quickly than this wheel. And so what happens is that wheel turns more quickly until the vehicle is oriented towards the light, at which time both sensors get the same energy. And as it gets closer to the light, the wheels move faster and it slams into the light and destroys it. And that's why that's called hate, right? So we can anthropomorphize these things. Here's this little very simple agent that is running around in its environment, and it looks like it's sensing and thinking and acting because it's like, I'm gonna slam into that light, but it's not really. If you want to go look at the slides later, you can see that this one becomes love because what this vehicle does is it turns toward the light, and then as it gets close to it, it just kind of stops and sits there adoring the light that it's found. A more relevant example is large language models. And so the question is, do LLMs think? And it's important to know, and I'm not sure how common this is among sort of users of LLMs, this little bit of knowledge is that all that LLMs do is they take an input, which is shown here in this light blue, and they use the input to predict the next word. They are literally going, if I say LLMs learn to, that's an input. The large language model, by basically looking at all the text on the internet and learning patterns in text, is trying to predict what's the next word going to be. And in this case, it's going to be predict. So what language models do is they just look at the entire input and go, I'm going to predict the next word. But now that it's predicted the next word, that becomes part of the input and it can do this sort of completion task. So it's called an autoregressive model because it's sort of learning to predict based on its own sort of output as it generates it. And so like, is that thinking? Is that like very different from the thermostat or one of Bratenberg's vehicles? So what I will say is that the models these days are actually getting much more sophisticated about that. So you may have heard about DeepSeek. So DeepSeek was a model that caught a lot of people by surprise. Actually, NVIDIA's stock dropped significantly after this model came out because they built it with cheaper hardware. Stock has recovered, of course, but one of the innovations that they had was they caused the model, once you gave it a question, to output this think tag, right? So it's like a little HTML tag that says, okay, you need to put output think and then some text in between and then end think. And then once you've ended thinking, you generate your answer in between answer tags. And so what does that do? The user sees the answer, but if you think about what the language model was doing, it says, here's the question, and then I'm just going to like say stuff to myself, basically, that's not going to be shown to the user. And then once I'm done saying stuff, I'll generate the answer. And that stuff in the think tag is exactly this inner monologue, right? So it's what you and I would do. So large language models these days are much better at it. So here's a very simple example. What color is the last on the visible spectrum? I personally have no idea, but here's the start of the thinking. Okay, so I need to figure out what color is the last one on the visible spectrum. Let's start by recalling what I know about light and colors. And the amazing thing is that this language model learned to do that, right? Nobody said, here's what your inner monologue should look like. But these language models are actually able to sort of ruminate internally um, and use all this information that they're sort of generating internally to later answer the question. All right, so I believe in some fashion that LLMs are thinking in some definition of that word that's useful. All right, so now what I want to do is I want to spend a few minutes, sorry, taking a slightly different slice through agents and what their abilities are. And so another way to think about agents is that they are autonomous. They can operate on their own. They can be reactive, so things can happen and they can just take action immediately. They can be proactive. They can take the initiative, and they can have social ability. And that social ability is particularly important in kind of multi-agent systems or when agents interact with humans. And I would claim that the thing that large language models have done by virtue of the fact that they are able to communicate by natural language so well is they've sort of democratized AI. They've opened it up to everybody because everybody can just go and type in a question. So what about autonomy? So AI agents can operate independently of humans. They can make their own decisions. Now, that doesn't mean that they're self-sufficient. So, um, when you go and talk to ChatGPT or Claude or any of these other models, you're typically the experience is that you're typing stuff in, it's typing stuff back, but many AI agents can use tools. So they have APIs that they can call. They can say, well, you want me to plan a trip for you. So what I'm going to do is I'm going to hit an API at a travel service. I'll do some queries. I'll gather that information. Maybe I'll call out to a model that has been trained using machine learning methods to do something, but they get to do that by themselves. They can decide what to do next. And so this autonomy is crucial for multi-step tasks, right? So older school AI systems, you would say, make a prediction about the price of an airline ticket to Portland tomorrow. And it would go do that thing, right? But it would never say, oh, he's asking about tomorrow, but maybe it's cheaper on, the day after. Let me look at that as well and give it to him. So, again, the examples are an LLM agent. You can say, book me a trip, and it'll go out and do lots of work for you. Or robotic vacuum is going to decide, where should it clean next. You don't have to tell it. It'll just go, I haven't cleaned the living room in a while. Let me go do that. Also, so they can go do things on their own, but they're also reactive. And the idea here is that they don't have to follow rigid scripts. So old school AI methods are more about I'm going to program in all of your logic. But they were brittle. So the term that was often used is brittle. That is, I could take a very common example is I could take an agent or an AI system that was great at playing checkers, but it would fail at chess or vice versa. So reactive agents are able to sort of respond when something unexpected happens. So a customer service chatbot notices that the user is frustrated, and then tries to escalate or tries to placate the customer. I've definitely used that technique in phone trees. I've tried to act angry. In fact, I have been angry, but they're apparently not paying attention to tone of voice. Or a warehouse robot. It's like, okay, I'm trying to take this package to this location, but a human gets in the path and goes, oh, that's not good. I'm going to react. They can also be proactive, which is they can initiate action, right? So they're not just responding to inputs in a reactive sense, but they can plan, they can anticipate needs, they can act without being explicitly asked. So, an example here is, like, okay, I'm heading to work. That that agent is looking at traffic, and wow, traffic is bad today. And so the agent will say, hey, Tim, you should probably leave 15 minutes early because you're going to be late to your first meeting because traffic is bad, right? Or, maybe a researcher is working on a paper on a particular topic and the assistant is watching that, this LLM, and it goes, oh, I bet they're going to want to do a literature review on that topic. Let me go ahead and like set that up for them. And then the final element is this sort of social ability. And um, everything we've talked about to this point has been sort of let's think about a single agent that's doing thing, but there's all this work on multi-agent systems, which again has been around for a long time. When I was a grad student in the early to mid 1990s, there was a professor at my university who was well known at the time for doing work on multi-agent systems. So been around forever. Human AI collaboration, or sort of human computer interaction is another area. So in multi-agent systems, the agents have to be able to manage their own tasks, but they also have to be able to interact with other agents or with humans. And so, maybe a logistics network has agents that are negotiating load distributions, or an AI teammate is explaining something to a human partner or trying to engage them in a cooperative task. Um, so what's the difference, right? So now that we've talked a lot about agents and we've looked at a couple of different ways that you can think about what they are and what they do, you've got traditional AI. I often call it old school AI. But those systems often were rule-based. So they depended a lot on humans sitting down and encoding knowledge and saying, here's how this domain works, and here are the rules that you need to pay attention to. They were sort of passive in the sense that you had to tell the agent, I would like you, or the AI system, I'd like you to do this thing for me now. Um, they tended to be siloed because, again, they depended on humans to encode the knowledge manually. And to do that, you kind of have to stay inside of a silo, right? Really hard 15, 20 years ago to think about providing very broad knowledge. And so they were sort of focused on single tasks and they required explicit instruction. So That's the kind of traditional AI side of things. Agentic AI, and I want to make a point here in just a second, is again, they're autonomous. They can adapt in real time. They can take initiative. They can interact with other agents. They can make decisions proactively. And again, the reason we can do that now is because of large language models. So um, there was a, an opinion piece that was written recently by Rich Sutton, who invented reinforcement learning for his PhD thesis, which is a remarkable feat. So he spawned this entire field. And he wrote a piece about what he called the bitter lesson. And he said the bitter lesson of AI is that hand coding knowledge is a dead end. And what machine learning has discovered is that the right way to do it is to allow the data to speak for itself, to build systems that are able to acquire knowledge from data. And so LLMs are sort of the the almost the final nail in the old school AI coffin because they show that you can build these amazingly powerful, knowledgeable, adaptive, flexible systems by essentially slurping into the all the world's text and sort of learning to predict the next word. It's much more complicated than that, but that's essentially it. So if people are talking about agentic AI, really what they mean is we are now doing agents in the 2020s with very powerful base agents. Whereas in the 1990s, when I was a grad student, people were doing work on agents, but the agents were just sort of dumb and not very capable, right? So, okay. So what I'd like to do is talk about just to kind of wrap things up, is to talk about a few use cases. Um, Here are a couple of just design patterns. So let's think about how you might use agents in a couple of cases. So here, this reflection pattern is super common these days. And the reflect so it's up here. The reflection pattern looks like this. I I have a prompt and I'm going to hand it to a large language model. So um what I might do is I might say, I need some marketing material. Here's sort of what I'm targeting. It's I don't know, top of funnel, and I'm targeting people in this particular industry, companies of this size. And so you hand it to an LLM, and the LLM will be very happy to generate that for you. So you get this output text. But then, interestingly enough, you could take that text and hand it back to exactly the same LLM, right? So you can say, "Hey, LLM, um, I needed some marketing material. Here's what you wrote, or I wrote, or another LLM wrote. Could you please like reflect on it and see if you can improve it, right?" And so what happens in that case is that it goes, "Oh yeah, I'll change it." And in fact, I have written text and I've handed it to LLMs and I'm saying, can you make it better? And you could do that forever, right? It will just sit there and modify your text forever in that loop, right? So just one of these days I want an LLM to go, nah, that looks really good, Tim. I can't make it any better, but they never do. So this reflection pattern is basically answer a question, but then tell me, how do you like that response? And it turns out that that's an agentic pattern that's super useful, right? So another pattern is tool use. So in this case, you have a prompt and there's a system that knows how to map those prompts into individual tools. So for example, LLMs, large language models, if you ask them to do math natively, they're pretty poor at it. Well, they're surprisingly good for a language model, but if you ask it to multiply, I don't know, two four-digit numbers or add, I don't know, two seven-digit numbers. It's kind of hit or miss as to whether we get it right. But these days, you can have tools. And it turns out that you can actually write code that says, if I see this kind of thing in a prompt, that means you need to probably use this tool. So you could write code that says, oh, hey, if I see the prompt is asking for some mathematical manipulation, what you need to do, LLM, is extract that out into a slightly structured format and hand it off to this tool, right? So there are lots of tools that will allow you to do that. So here's how you know, here's a way to recognize when the tool is being used. Here's what you need to extract from the prompt to hand off to the tool. Here's how you call the tool. Here's how you take the response from the tool back and interpret that so that you can provide a response to it. So, again, in this case, it's it is the agent has access to a suite of tools and it can flexibly decide which ones it wants to use, right? Planning is another one where LLMs these days are great at you could say, hey, how am I going to go about achieving this task? And you can say, I need to do the following. I need to plan a trip to Portland, for example, and I give it some parameters. And it'll go, okay, well, what I need to know is I need to know when you're flying out, when are you flying back. I need to make outgoing flights. I need to get a rental car, a variety of other things. And then you hand it off to a single agent, right, to execute. So another language model, or maybe it's using a tool to go out and talk to the internet. And then it gathers the information back, but it can also sort of autonomously decide, oh, that I don't know, that doesn't seem great. Tim doesn't like to, he's like he always says he's too old to do red eyes, which I am. Let's not do a red eye, or we'll do something else, right? And so this sort of planning, decomposing a problem, using single agents to solve pieces of it, synthesizing a solution, maybe reflecting on the quality of that solution, and then replanning if you need to, right? So now you can see how these design principles are kind of feeding into one another. And then there's just sort of the kind of standard multi-agent pattern where actually if you look at OpenAI has I think it's a five-stage roadmap to artificial general intelligence. Um, and I think they're on step two, maybe at this point. Step five is fully autonomous organizations. So they want to be able to have an organization that is all AI agents, no human involvement, which I don't know, you can feel how you want about that goal, but that's sort of the ultimate version of this multi-agent pattern where you've got software engineering agents, you've got project manager agents, you've got content developers, you've got market researchers, but in the multi-agent pattern, you have to think about what are the roles the agents are going to play, how do they coordinate among themselves. Um, Much more complicated than doing sort of things like this, where even in the reflection pattern, maybe it's just the same LLM that's kind of reflecting on its own work, right? Okay, so just a couple more slides. Let's look at a couple of use cases. Here's sales. So the traditional approach is you've got a sales development representative, an SDR, that's every day researching prospects, drafting emails, messing around in the CRM. That's a hard job. Very important. It's a hard job. So you get burnout, you get inefficiency. Really what you want is an SDR that's going to be very personal when they are reaching out to prospects, but it's really hard to scale that. And so if you miss follow-ups, you're going to miss revenue. And on the other hand, an agentic approach might be, hey, let's have an agent that's going to look at the CRM, go grab some LinkedIn profiles, look at email threads, and then the agent can think and say, well, I don't know, which leads look like they're the most promising. So I'm going to prioritize leads. Once I prioritize leads, what I can do is I can, like, all right, well, how am I going to go about reaching out to these people? I can draft emails. Those emails can be tailored to the individuals. And then you can send the emails, you can record them, schedule follow-ups, right? And so the idea is, and you have an agent sort of doing a lot of this work, and can sort of every once in a while like nudge your SDR and say, hey, maybe you should book a meeting with this individual. So, and impact could be 3 to 5 times productivity gain, right? Higher personalization, lower burnout. Now, I think it is important in this case to think about what's the fate of the poor SDR? So is it the case that the SDR is going to be out of a job? What I would say is that what the agent is going to do is going to take some of the drudge work out of it, right? So the agent is going to comb through nobody wants to go to LinkedIn and I don't know, copy information and enter it into a CRM. What a good SDR would like to do is to go, oh, this looks like a really good lead. I'm going to reach out to that person on the phone and I'm going to try and really connect with them, given access to a bunch of information. So at Synaptic, like we get this question all the time. We do a lot of work in the legal profession, and people say, well, are our paralegals going to be out of a job? In every case that we've seen so far, the AI system has taken over the part of the job that's less interesting and less fun, and it allows those people to do work that seems to be more fulfilling. I'm sure there are other use cases out there, but we haven't run across those, at least in the projects that we've done. So last use case is just enterprise IT troubleshooting. Traditionally, like networks generate thousands of log events daily, right? And it's the standard kind of problem, which is it's like when you're in a hospital, everything is beeping all the time and nobody pays attention to it. And so just identifying things that are important is hard, but then diagnosing the root causes can take forever. It's a slow process. Escalation chains are slow, right? Like, I don't know, do I tell my boss about this or do I not? And then downtime is really expensive. So on the agentic side, though, you can have agents doing that. They can look at the logs and the alerts. They can start thinking about what root causes are. So, interestingly enough, a very common thing that you can do these days with LLMs and agents is just pose the same question 10 times. Hey, can you look at this data? Tell me what you think is going on. And because LLMs and LLM based agents are non-deterministic, right? They don't do the same thing every time. They'll give you 10 different answers. They're slightly different. You can take those 10 answers, you can hand those to another agent and say, hey, what are the themes that are emerging here? And that agent can say, well, like it looks like either that router's down or this other thing's going on, right? It's probably that router, but it could be this other thing. And then, you can surface that to the DevOps team and they can kind of collaborate, right? So again, humans, I've looked through event logs myself. We had a client one time that had um, terabytes of event logs. It's unbelievably painful. If you can have a system do it, it's great, right? The other thing is that sort of multi-agent setup is going to parallelize across services, and then you resolve these things faster, and typically you're going to have less downtime. So okay, so wrapping up, I have just a couple of slides. I would beware provider hype. So, um, three of us from Synaptic went to a trade show a year ago. Um, and everything was agentic AI. There must have been 10, 15 companies there that were saying, hey, I've got a system that's going to help you build AI agents. And, so here I did the same thing. I did, agentic AI businesses or what I can't remember what the query was. But again, there's, Agentic AI is raising $4 million to scale portfolio of agentic AI companies and so on, right? So I think what you have to do is you just have to be careful as you're thinking about building agentic systems. You don't want to kind of bet on a company that just got their seed round and then they're going to be gone in 3 months. So like just be a kind of careful consumer. Um, Now, here's a random diagram that I don't expect you to understand, but it's just starting to show that when you build agentic systems that are complicated, that you get lots of moving parts and lots of boxes, and there's a lot that you can do. And so when I think about how would a company go about using AI agents. It's interestingly really similar to the way you would use traditional AI, but you evaluate the pain points, right? So sort of internally facing and externally facing. Um, I always tend to think it's a very good idea to start small. So I would not say, okay, we're going to jump ahead to OpenAI's fifth level of AGI and we're going to fully, automate our entire company. Start with a small thing, but focus on impact, right? So what's a thing, if we've looked at the pain points and thought about them carefully, what's a thing that we think we can do that's tractable where an AI agent might help us that somebody's actually going to feel a benefit to it? I'd say work with a trusted partner to explore that feasibility. So again, tons of companies out there that are kind of jumping into the space because it's hot, there are buzzwords, and there's VC money around. But you want to make sure that they know what they're doing, right? And so there are people who know what they're doing in AI and ML generally. There are people who have experience with language models. There are people who have experience building agentic systems. So I think it's important to have a guide that you can trust to just sort of walk through this for you or with you and help you understand the trade-offs, the concerns, what are things to watch out for. And importantly, you got to get stakeholder buy-in. So um, we run into people all the time at companies on the tech side who are super enthusiastic, right? Because it's a really fun time to be doing this kind of work. And they're like, we would love to do this stuff, but um, if the C-suite's not bought in, then they can be very skeptical and put the brakes on it. And so I think, again, like the trusted partner can often help you get that stakeholder buy-in because they've done it in other cases. I'd say be realistic about the upside. You don't want to oversell things. Again, kind of going back to the hyper hallelujah thing. And then one thing that I've seen be problematic a few times, um, maybe not with the stakeholders or the sort of the tech people who are really interested in it, but other people inside the organization, is that you have to remember that agents, like people, are unpredictable. So you don't expect one of your employees to be perfect all the time, to always get the right answer. You expect them to be productive. They'll make mistakes occasionally, but they are very worth the investment of your money and your time because they're helping move your business forward. I think agents are going to be exactly the same way. So they are a little unpredictable. You can do things to try and make them more predictable, but you kind of have to coach them. I I think about what I've learned about interacting with language models over the past few years. And I think it's a skill that you acquire through time of just understanding how do I talk to them? How do I how do I say things in a way that's going to motivate them to sort of do the thing I want them to do instead of the thing that their training data is sort of guiding them towards. So anyway, so just like some things to think about as you move into this space. So I would say thank you very much for listening. I've got one more slide. I can't remember if Sam's going to jump in here or not, or if we're going to do questions, but I'm going to go here. So, Sam,
Yeah,
I'll
we
yeah.
do have some questions that have come in, so I'll get to those. Also, just want to invite everybody to our next webinar, which is next month on August 26th. I'm going to put a link to the invitation to that in the chat, so hopefully you can all join us. We will be sharing practical methods for making the most out of small data sets in this next session. So, Tim, to jump to the first question we got. As many organizations are implementing MCP and agentic AI type systems, what are the critical topics architects need to consider when designing? For example, security, retraining, etc. And as a
Hmm.
follow-up, what is your biggest architect solution learnings with respect to MCP and agentic AI?
Right. So I think that the thing that you need to worry about the most or focus on the most with agentic systems is grappling with the non-determinism of it. So, and I mean that in two ways, because I think with your standard software development lifecycle, you think about sprint planning. I'm going to spend, 2 weeks on a sprint and we're going to parcel out this work that we're going to do and we're going to have our engineering resources. And I think people are really good at estimating how long things take. I think with agentic AI, there's still a bit more experimentation that's involved. So the underlying phenomenon that you're dealing with, the thing that your core tool is a large language model, which again is hard to understand, although people are making strides in doing that. It's kind of non-deterministic. And so you have to be prepared to spend a lot of time to kind of bring that agent to heel to make it do the thing that you really want to do. So, and again, I think that tends to be a stumbling block with people who are in an organization who are consumers of it, because if the agent goes off and does some work for you and says, "Hey, I found this really hot prospect. I've scraped their information from LinkedIn," and then the SDR looks at it and goes, "Hey, I've talked to this person 3 times and they're not interested," then they start to lose faith in it. But it's an educational process. So I would say that the gotcha is kind of thinking about massaging the input, massaging the output, bringing to bear data that you have internally and knowledge that you have internally to ensure that the agent is going to kind of go in the right direction generally for you.
Okay, great. We have more questions coming in. So everyone can just pop them in that Q&A if you have a question for Tim. Our next question is, if your agent consistently gives incorrect questions, how do you find the root cause if it's complex like your last diagram?
Oh, right. So you're saying, all right. So I'm going to interpret that as saying that the agent is um like you're tasking it to do something and you are not getting the output that you're looking for, right? So that's a great question, right? So the question is then how do you go about debugging these things? You know, it turns out that it's very much like a kind of standard software debugging problem, which is there is going to be information that flows, right? So the diagram is complicated, but it's complicated because what's happening is you're getting information from various sources. You have internal knowledge. The language model itself has a tremendous amount of world knowledge baked into its, often billions of parameters. And then there are these kind of complicated connections among things. But I mean, what I've seen for staff inside Synaptic, they're trying to figure out where an agentic system is going wrong, is they do exactly the standard debugging process, right? Like sort of walking back through it, trying to figure out where the information starts looking wrong, and then trying to dive in and figure out what the cause of that is. Now, that part can be hard sometimes, again, because the language models themselves are so powerful. Um, but typically, the levers that you have to move are often the prompts, right? So in agentic workflows, it's often about, I'm going to say this to the agent. And then the agent is going to take some extra data and then they're going to produce a response. And so the work tends to be in how do I talk to the agent? What is it that I say to it? And how do I need to tweak that so that I get the right output? So again, they're complicated. Large software systems are complicated, but they're sort of modular in the sense that an agent gets inputs and produces outputs, and you can kind of break that apart and look and see where the information starts to get garbled.
Okay, great. Thanks, Tim. Next question. Do you see a change in resourcing of projects to be more focused on QA of agents?
I guess I'd resourcing of projects to be more focused. Right. So I'm not sure exactly what the question is. I will say that we see at Synaptic lots of people interested in um, chatbots, which is a kind of agent, right? So it is definitely the case that companies are seeing low-hanging fruit around call centers or help desks, which are typically staffed by humans, help desks that are not staffed by humans, but that have old school systems underneath them that are AI tend to be poor. So there's a lot of interest in that. And we had a call with a company recently that was sort of saying, okay, how can we what's the staffing that we need to be able to manage a process of being able to stand that up? Now, I do think that it's one of those cases where there's a little bit of short-term pain for a long-term gain. So companies are busy, they're trying to make money, they've got a lot of efforts underway, and pulling staff away to sort of be the domain experts or the SMEs on a project like this can be painful, but that investment often pays off because then it saves you resources in the long term. I hope I answered that question. If I didn't answer it with the intent that you had, please feel free to reach out and I'm happy to give you a more focused answer.
Okay, great. If there's any other questions, please pop them in there, or else we are going to wrap up the presentation. Great information, Tim. Thanks again for joining us. Tim will be presenting next month's webinar as well. And if any other questions come in, we will be sending out an email with the recording and the slides from today. You can respond to that email to get in touch with Tim or with us if with any other information on this topic that you want to learn about. Would love to hear from you all. And with that, I'm going to close out the presentation, and I hope everyone has a good rest of their day.